The fundamental theorem of algebra really brings all of this factoring together. What it says is if p is a polynomial of degree greater than 1, then p of x is equal to 0 has exactly n roots, including multiple and complex roots. Other ways you can say this is it has at least one complex 0. Now remember, complex means a plus bi. And if b is 0, we're still going to count this as a complex root. Another way to put this is that a polynomial will have n linear factors. Okay, let's just look at this one. The first thing you want to do when you're fully factoring one of these is to determine the number of positive roots and the number of negative roots. So how many possible positive roots do I have? Let's see, it's going to go from 1. Let me count. I'm going to use Descartes' rule of signs. So this is 1, 2, 3, 4. So this is telling me the number of positive roots, 2, 3, 4, is either 4, 2, or 0. What about the number of negative roots? Okay, when I go through and I'm going to change my signs, this becomes negative, positive, 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 positive. This has one sign change. Now remember, I'm using the trick that only the sign of the odd powers will change. So Descartes' rule of signs tells me I will have exactly one negative root. So once I've determined that, I'm just going to hang on to that. Because the next thing I'm going to look for is my rational roots. What possible rational roots do I have? Well, the coefficient of x to the 5th is 1. So my possible rational roots are plus or minus 1, plus or minus 2, and plus or minus 4. Those are the only possible rational roots I have, and I know one of them has to be negative. Exactly one of these has to be negative. So let me just start in the middle. Let me see if negative 2 is a root. So I'm going to use synthetic division. 1, negative 1, negative 3, 3, negative 4, 4. Let's see if this one is a root. So this is 2. 2 times, this is 1. 1 times negative 2 is negative 2, negative 3, positive 6, 3, negative 6, negative 3, 6, 2, negative 4. Oh, yes. So negative 2 is a root. So I'm going to come down here and rewrite my polynomial. So I know my polynomial is x plus 2 times, now that's a 1, x to the 4th minus 3x cubed plus 3x squared minus 3x plus 2. Did I get those signs right? 1, negative 3, 3, negative 3, 2, 0. Okay, you remember, here is my remainder. All right, so I've got the only negative root possible. So I know here I'm going to have a maximum of how many positive roots? I'm going to have 1, 2, 3, 4. So I'm going to have 4, 2, or 0 positive roots. Now, my positive roots have changed because I've factored. So let me see what are my possible rational positive roots. Here my possible rational positive roots are plus or minus 1. Or how about let's just do plus 1. I'll do plus or minus 1, plus or minus 2. But I'm only going to check the positive ones because I know I've taken care of my negative root. So you see the value of the Descartes rule of sign. So let me try 2. Okay. So when I try 2, let's see, this is 1, -3, 3, -3, and 2. So bring down the 1. 1 times 2 is 2. -1, -2, 1, 2, -1. Oh, goodness gracious. Yes, this is another root. So I know my polynomial is x plus 2 times x minus 2 times, let's see what we're left with, x cubed minus x squared plus x minus 1. Now, I know my only other possible, I know I've got one positive root, so that means I have to have at least one more positive root. As soon as I find one positive root, I know it can't be 0. So let me see if I have another positive root. But the only thing it could be is 1 because I've got only 1 in my last place. So let me try 1. I'll try and squeeze it in here down at the bottom. So this is 1 minus 1, 1 minus 1. So this is 1, 0, 0, 1, 1, 0. Yes! All right, so I'm going to rewrite it up here. This is x plus 2, x minus 2. Now this is a root of 1, so this is x minus 1. And what am I left with? Okay, there's my remainder. So this is going to be x squared. I don't have a linear term, so it's plus 1. All right. Now, I see I've got 2 positive roots, 1 negative root, and now I've got a sum of squares. So this is going to be an imaginary root. So if I factor this fully over the complex plane, this is factored fully over the real plane, but to factor fully over the complex plane, this is going to be x plus 2, x minus 2, x minus 1, and this is a sum of squares, so this is going to be x plus the square root of -1, which is I, x minus I. I have 1, 2, 3, 4, 5 linear terms when I fully factor it over the complex plane.